In this video, we will finish the fundamental counting principle by going through a few more examples. It started on page 6, and this example, the one that we have left off, was example number 5, which is on page 8 in the booklet. So we will start with example number 6 on page 8 in the probability booklet. So you have it in front of you, and if you want to work, I would encourage you to work on a loose leaf of paper again, because there is going to be enough more room on that than in your notes. So we want to figure out how many even 3-digit numbers are possible using these same digits that we used in the previous example. The difference with example number 6 is that we want to have an even 3-digit number, whereas in example number 5 we wanted to have an odd. And so why is that different, or how does that change things? And you'll see that the last digit, the choices of the last digit, will depend on the choices of the first digit, or vice versa, because your first digit can't be a 0, which is also an even number. And so when you can't repeat digits, that's where it becomes a little bit dicey, or a little bit interesting. So let's get started with example number 6a, where we actually can repeat. So just as a reminder, we want to have a 3-digit number, which means we have 3 different events that we will choose from: the first digit, second digit, and the third digit. The first one can't be a 0 because you want to have a 3-digit number. The last digit should be even. And the middle digit can be any number that is left, because you can actually repeat. So this was question A. So from the digits 0 to 4, there are 3 different ones that are even. So we have 3 choices for our last digit. If it can't be a 0, then there are 4 choices that are left for the first digit, 4 options for the first digit. And for the middle digit, you can choose any of those because repetitions are allowed. And so therefore there are 5 options left for the middle digit. Okay, so to find out our total amount of outcomes, total possible outcomes, I would multiply those 3 together. 4 times 5 gives you 20, times 3 gives you 60 possible numbers. 3-digit numbers that are even. And so here's where we get to the second example, or the second part of this question, where you have no repetitions allowed. So to get us started, I will just draw our 3 different spinners here for our 3 different events, the 3 different digits. And now we'll put in the numbers that you can choose. So for the last digits, you can either choose a 0, a 2, or a 4, because it needs to be even. For the first digit, you can choose either 1, 2, 3, 4, because you can't choose the 0, because you want to have 3-digit numbers. So in the second digit, you can choose anything, but it just can't repeat the ones from the other the digits that you already have chosen. So this is going to be interesting, because we have a restriction on the last one that will affect the restriction on the first one. And the reason why is because you can't have a 0 at the end and at the beginning, but you can have a 0 at the end. So in the previous example, example number 5, this one didn't really affect this one, except for that you can't repeat numbers, but you weren't allowed to choose one here that you couldn't choose in the front. So let me explain this by going through an example. When I choose the 0 here, so my 0 is chosen for the last digit, then I can't choose a 0 anymore here. That means I have 4 options for the first digit. However, if I choose a 2 here, then my first digit, I can't choose a 2 anymore. So how many options do I have for my first digit now? Only 3. So remember, when I chose a 0, I had 4 options. When I chose a 2, I had 3 options for my first digit. When I choose a 4, I also have just 3 options for the first digit. And so what you see is 2 different kinds of events. One where the last one is chosen to be the 0, that gives you 4 options for the first digit. And the other one where the last one is chosen not to be a 0, and that leaves you with 3 options for the first digit. So now we need to separate our 2 different kinds of events. We need to separate that into 2 different countings, into 2 different fundamental countings, and figure them out individually. And then once we have the possible outcomes for the first kind of event, and then we have the same for the second kind of event, once we have those 2 different possible outcomes, we can combine them, we can add them together to figure out our total number of outcomes. So every time you see that your one choice, your one event will cause another event to change the number of options in this event, in another event, then you need to separate that into 2 different types of events. And we call those 2 different types of events mutually exclusive. So we have 2 mutually exclusive events, and those 2 mutually exclusive events are the following. The first one is where the last digit is a 0, and the second one is where the last digit is not a 0. And we need to now figure out the outcomes, the possible outcomes for this case, and the possible outcomes for this case. And to figure out our total, we add those 2 together. So let's look at the first one here. Last digit is not a 0. We have 3 different events. So here's the first digit, second digit, and the third digit. The last one is a 0, so it needs to be a 0. And the first digit can't be a 0, and it can't be the last digit either. And the middle digit can be anything that is left. All right, if the last digit has to be a 0, then how many options do I have? Only 1. Now, if the first digit can be, and if you want to, you can look at the spinners here, right, to help you out. If the first digit can't be a 0 and it can't be the last one, which in our case is the 0, then for the first digit, I have 4 different options. And since I can't choose either one of these that I've chosen here, for the middle digit, I have 3 different options left. So now I have 4 options for the first one, 3 options for the middle one, and 1 option for the last one. When I multiply them together, then I figure out how many possible outcomes there are for this one. The next one, the last digit is not 0. Again, we will start with 3 different events. In the first event, for the first digit, we can't have a 0. And we shouldn't have the last digit. Now, in the last digit, for the last digit, we can't have a 0. And then for the middle digit, we can only use digits that are not chosen already. And so now we need to think about our number of options for each one. So since our last one can't be a 0, that means we have 2 options for our last one. Okay? But since we have chosen one of these 2 options, that choice does not exist anymore for our first digit anymore here. And that means that we only have 3 choices left for our first digit. And so now Again, we've chosen one of these, we've chosen another one of the three that was left. That means we only have 3 choices left for the middle digit. And when we multiply these 3 together, we will find out the outcomes, possible outcomes for the number of the 3-digit numbers where the last digit is not a 0. And again, these two are mutually exclusive because your choice in the last digit changed the number of options for your first digit. Multiply these 3 together, you get 4 times 3, which is 12 times 1. That gives you 12. There are 12 different 3-digit numbers where the last digit is a 0. And you can probably come up with those by yourself on your own. And then the last one here is where the last digit is not a 0. There are 3 times 3 times 2, which is 9 times 2, which is 18 different possible outcomes. Now, altogether, there are 18 plus 12 different outcomes. And that is equal to 30 different possible numbers. And so that's what you need to think of when you are looking at letters or numbers where the first and the last kind of depend on each other, where choosing, depending on what your choice is for the last, will affect the number of choices for another event. Not just the first one, but just any other event. Then you have to split it up into 2 different events that you calculate individually, and then you add them together to figure out your total possible number of outcomes. So just be careful with those kinds of things. And that finishes example number 6. So let's go to example number 7. How many standard car license plates are there? So no individualized ones, but just the standard license plates in Manitoba. So a standard car license plate in Manitoba usually has 3 letters. And it has 3 digits. And in addition to that, each one of these can be repeated. So you could have AAA and 111. So these ones can be repeated. So repetitions are allowed. All right. So if we can choose 3 letters and we can choose 3 digits afterwards, we have 6 different events. And where the first 3 are letters and the last 3 are digits. Now, how many options do we have to pick our first letter? 26. And the same thing happens for the other letters because you can repeat letters. How many options do we have for 1 digit? For the first digits, there are 10, second digit 10 as well, and so on. And the reason again why is because we can repeat the same digit. So when we multiply all of these together, we get the number of possible car license plates that we can have in Manitoba. And that gives you an answer of 17,576,000 plates. Okay, so that's how many options there are if we stick with 3 letters and 3 digits that can be repeated. Now, if you remember in the last unit, we had one question in the quadratic equations where we calculated the population of Canada in 2050, and that was 51 million. So in Manitoba, the population of 17 million, it'll take a while until we get there. Definitely another couple of decades. All right, example number 8. How many multiples of 5 are there that are less than 1,000? So here we get into a little bit of an interesting concept again. So here's example number 8. And we want to find multiples of 5 less than 1,000. And when you look at the number 1,000, it has 4 digits. The first number that is less than 1,000 has 3 digits. 999 has 3 digits. Now, you don't need to only look for 3-digit numbers, but you can also have 2-digit numbers that are less than 1,000, and you can have 1-digit numbers. Now, each one of those is going to be different. It needs to be calculated individually. So we call those mutually exclusive events. So we have 3 different mutually exclusive events. The first one is where you have 3 digits. The second one is where we have 2 digits. And the last one is where we only have 1 digit. And those are our 3 mutually exclusive events. And the reason why those are mutually exclusive hopefully makes sense, because here we have 3 events, here we have 2 events, here we have 1 event. In this one here, we now have to think about our restrictions. What are we allowed to use for each one of those digits? And if you go back to the example, they have to be multiples of 5, which means that the last digit has to be either a 0 or a 5. So the last digit has to be a 0 or a 5. Same thing with this one, and the same thing with this one. Now, the first digit in the 3 digits numbers, the first digit can't be a 0, and the second digit, and the second digit can be anything. And in the second digit, for 2 digits, our first digit again can't be a 0, because that would not make it 2 digits long. And here, 0 is actually not a multiple of 5, because you always go for numbers. Multiples are numbers that are 5 and higher. So multiples of 5 would be 5, 10, and so on. So 0 is actually not an option in the 1 digit. The only option is the number 5. All right. Now this question, you hopefully look at, this can't be a 0, but this can be a 0. So do I need to think about how they affect each other? Well, no, you don't. And the reason why in this case, the reason what makes this one, again, different than example 6b is the fact that here we can have repetitions and here we couldn't. All right? And so this, the example 6b is special because you can't repeat, and the digit that you chose for the last the choices that you had for the last digits affected your choices that you had for the first digit. But the important thing is we can repeat, and so therefore we don't have to worry about that restriction here. All right, so we have 2 choices for the last digit because we can only choose 0 or 5. We have how many choices for the first? Hopefully 9 makes sense. Anything from 1 to 9, so 9 different choices for the first digit. And then any other choices for the middle digit, so we have 10 choices for the middle digit left. And now the next one, we have 2 choices again for the last digit here, because we can either choose a 0 or a 5. And we have 9 digits to choose from for our first digit here. So we have 9 options there. And now for the last one, since we can only choose a 5, that means we only have 1 choice for the last digit. So now when you look at these three options here, these three we have to multiply with each other to give me the total possible outcomes for 3 digits. These two we have to multiply, and this one is on its own. Once we found this and this, then we can add these three numbers together to give us the total number of outcomes. Now this is 9 times 10, which is 90, times 2, which is 180. 9 times 2 is 18, and the last one is 1. So here's another thing that I want to point out. Since you can either have 3 digits or 2 digits or 1 digit, that means that you're adding them together. Another way of writing or, you can use the symbol, this symbol that is a curve that almost looks like an N without the tail in the front. That is your or symbol, and we'll use that later a little bit more. And when we have 3 different events that are mutually exclusive, we add those 3 different events together. So whenever you see the word or you think the word or, you're adding them together. Now, what I also want you to see is then that for 3 digits, you need to have 1 digit and a second digit and a third one. So whenever you hear the word and, you are multiplying together when you're counting the number of possible outcomes. And so I will point this out when we get to go through this unit. But every time you hear the word or, you're adding possible number of outcomes together. Whenever you hear the word and or think the word and, you're multiplying possible outcomes together. Now the symbol that we use to show and is an upside down curve. It looks like that. And again, we will see this more often as we go along in this course. So if you add all of these together, you will get 199 possible numbers. So now let's look at the last example, and we'll change the last example, example number 9, and we'll do the following. We will find out how many 4-character passwords are possible that meet this criteria. It has to be at least 3 letters. Okay, so forget about this. We will figure out how many 4-character passwords are possible with at least 3 letters. So anytime you see this phrase, these 2 words, at least, every time you see that phrase, those 2 words, you have to remember that there are more than one option, which means there are a few exclusive events. Okay, in this case we could have said how many numbers are there with at least 1 digit. Well, then we have 1 digit or 2 digits or 3 digits. And here's the same thing. We have a few outcomes, a few mutually exclusive events. One of them is where we have 3 letters, or we could have 4 letters. So let's write that in here first. Two mutually exclusive events that we can have, and one of those is 3 letters, and the other one is 4 letters. Now we will go with the first one. We have 4 different characters that we want to use, so 4 different events. And with the 4 letters, we also have 4 different events. Okay, when we have 3 letters, now it doesn't tell us where the 3 letters need to be. So that means they could be here, 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 or here, 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 and so on. So what you're basically doing is you will have 4 different options here. And that means you need to actually figure out those 4 options individually. Now, you need to realize that, or hopefully you realize that if I change the letter from here, the digit from here to here to here, the answer, the product of these four numbers is going to be the same for either one of them. So let me explain this by doing one of them. So let's say I have the digit for 3 letters. I will choose the first character to be a digit and the last 3 to be a letter. So this means I have 10 options for the first digit, for the first character. I will have 26 options for the second, 26 for the next, and 26 for the next. Now, I can repeat, and that's why this number doesn't change. If I move my digit to the second place and the letter to the first, then I still have the same numbers on the top, the same number of options, right? So my product will stay the same no matter where my digit is, but there will be 4 of these options here. That means you can just multiply this by 4 in the beginning, or you can figure out each one of them separately and then add them all together. Those are your 2 options. Okay, so I will multiply this by 4, and the reason why is because I will have the 4 represents my position of the digit. So digit position. And now I can work on the 4 letters. Since I have 4 letters, that means my first digit, first character needs to be a letter. The second and third and fourth, all of them have to be a letter. That is 26 choices for each one of those, or 26 options for each one of those. And to figure out what this is, I will multiply these together, how many outcomes there are, multiply them all together. And to figure out how many outcomes there are for 4 letters, I would multiply those together as well. Figure out the total for this, figure out the total for this, and then you would add them together because these 2 are mutually exclusive. And your answer is going to be 1,160,016 codes. And that finishes a whole bunch of examples that show you how to use the fundamental counting principles in a variety of situations. And that should help you finish the questions on the pages 9 all the way to 10. And there are 26 questions, and some of them will take a little bit of time to think through, but you have all the understanding you need to finish those 26 questions now.